This video is going to show you how to apply different laws of logarithm to find the values of different types of logarithm expressions. In this question, there are 3 parts in total. In part A, we are going to find log to the base 381. The first thing we can do is to identify what will be the base and what will be the number inside the logarithm. From this one, we can see that the base is 3 and the number inside the logarithm is 81. Then we can try to look at the relationship between 3 and 81. Of course, all of us know that 81 is a multiple of 3, but more importantly, 81 can be presented as 3 to the power 4, which can be expressed as a certain power of the base. Then we are going to present the working in this way. Log to the base 381. The step 1, we are going to convert 81 to be 3 to the power 4. And then we can see that there is a power 4 inside the logarithm. And then by this rule, we will be able to move the power to the front as a coefficient. So it becomes 4 times log to the base 3 and then 3. Then from this step, we can see that the base and the number inside the logarithm will be the same. Then we can try to use this property such that log to the base 3 can be presented as positive 1. So that the result becomes 4 times 1, which will be positive 4. And then for part B, we are going to find the value of the sum of 2 different logarithms, log to the base 6(2) plus log to the base 6(3). If we are going to add the multiple logarithm terms together, and at the same time we know that the base of each logarithm term will be the same, then we will be able to apply this particular rule, such that multiple logarithms can be combined into one single logarithm. And then the resulting number inside the final single logarithm will be just the product of the original individual terms. Once we confirm that they are referring to the same base, then we will be able to apply this to combine them as a single logarithm. And then simplify 2 times 3, then we will be able to see that this one would be a bit similar to what we have just done in part A. We can see that the base and the number inside the logarithm are the same again. Then by using the same property, we will be able to conclude that this outcome will be equals to 1. Lastly, for the part C, we have to be vigilant about the base here, as we can see that we are going to do the subtraction of 2 different logarithm terms. When we are going to look at this carefully, we can see that the base for the first term is 4, while the base for the second term is 2. If those bases are different, we cannot apply the another trivial formula to combine them as a single logarithm. We have to apply the change of base formula to make sure that all the bases for each term will be the same. Here is a tip for you, that is, when you see that there are 2 bases here, usually you're going to change the larger base to the smaller base. For example, in part C, we have the 2 different bases, 4 and 2. And we are going to change the base 4 to be the base 2 as well. Okay, so we can start from this step, and then our goal is to change from the base 4 to the base 2. Then we will be able to apply this change of base formula to change the base of the first term from 4 to 2. By applying this change of base formula, we will be able to express the first term as a fraction, where the numerator and the denominator would be in terms of log to the base 2. Then let's have a look at this. The original number inside the logarithm is 8, so that I'm going to copy the number 8 to the top. And then we can see that the original base was 4. Then we will try to put the original base at the bottom. And then the second term will be unchanged at this moment. And then I would like to make some changes for the denominator for the first term. I would like to present positive 4 as 2 to the power 2. And then for the second term, I would like to present the square root of 8 as 8 to the power of 1 over 2. Then from the denominator of the first term as well as the second term, we can see that there is a power inside the logarithm. And by using the similar rule, we will be able to move those two to the front of each term, such that it becomes 2 times log to the base 2 minus 1 over 2 times log to the base 8. By using this property, we can see that log to the base 2 is equal to 1. So that we will be able to present the first term as 1 over 2 log to the base 8. But we find that the first term and the second term are the same, so that when we are going to do the subtraction, we will be able to conclude that the result is 0.